Hello everybody, my name is Jeffrey. Last tutorial I ended last tutorial with our world model class. In this tutorial we are going to create we're going to start creating our world model generator class, and yeah, so that's what we're going to do. So go over to your model package and create a new class called world model generator. So we'll create a public static method, and we won't be returning anything, and we'll call the method process segment, and we'll just take in a segment and call it seg. Yeah, it's short for segment. Well, at least for me it's short for segment. I don't know if it reminds you of anything, but yeah, for me. First of all, the things that we're going to need, we're going to specify them in before here, and we'll make them private static variables. Why are we specifying every single variable we need over here and not in our method itself on the fly? Well, that's basically allocating space for variables, and disallocating it takes up time, and we want this to take as less time as possible. So this method should run as quick as possible so that we can update as many world models as possible, as well as do other things at the same time. So this method should not take very much of our processing power, and yeah, that's why we're doing everything so in order to for it to run as efficient as possible and return as few amount of vertices, as few vertices as possible, because we don't want a high amount of vertices as well, because that will make it so that the graphics card will take up more time. Everything needs to be fast. So what we're going to need: a private static tile type array called mask. This will be, well, it will create a mask of our segment. So new tile type array, and the length will be this. So import it, yeah, and a private static boolean array called done, because we want to keep track of which tiles we already did. Why are we doing this? Well, I'm going to use the greedy mesh generation. Basically, if two tiles of the same type are next to each other, it will create them as one big, well, not square, but one quad. And therefore it will only take up 2 triangles instead of 4, and if you're dealing with larger amount of tiles of the same type next to each other, it can be a big difference. So that's why we're going with greedy mesh generation. So new boolean array 4096. This time I said it right. So we need a private static tile called tile, and a private static tile type. So import everything as well. Private static int x, y, and z for looping through all of the coordinates. Private static int y underscore and z underscore. These are for, as you can probably remember, over here we're going to calculate what these are a little bit fast. Well, we want to calculate them only once every so much time and not calculate them 4,000 times, but we can do it in fewer times. So yeah, we'll have to, for example, we'll only have to calculate the y thingy about 16 times for the entire segment. Well, times 6, because we're going to loop through all of the 6 sides of the segment. But yeah, it saves a lot of time, and we want to save time. So private static int width equals 0 and int. Can we do this? No, I have to put a comma. Height equals 0. Private static int sum. Private static int I and j for looping through things. Private static int q and p. These will be basically equivalent to y, w and h. Private static boolean done underscore private static boolean continue underscore and private static boolean. Well, let's see what else we'll need. So first things first, we're going to create the mask. So for and we don't have to put integer in front of this because we already initiated this integer. So I equals 0. I is less than 4096 and I plus plus no I plus plus, yes. Tile equals segment dot get seg dot get tile I. Sorry. And I forgot to make this I, well, it was capitalized and it shouldn't be. Now if tile equals null, we are not going to add it to the mask, so mask sub I equals tile type dot air. Else if not tile dot is visible, mask sub I will also equal tile type dot air, and otherwise else mask sub I equals block, tile dot get type. And you can basically add another exception to this list and just go on and on with exceptions, but yeah. Next thing, now we're going to loop through the sides and generate the model. So for I equals 0, I is less than 6, and I plus plus. So now I is equal to the side. So I'll just put some comments over here. Tile I is tile ID. Yeah, let's call it tile ID. No, not tile ID. Tile number. And here I is side. So first of all, what we're going to do, we're going to create the done array, the boolean array done. Basically this is going to check if the side of the tiles are visible. So for j equals 0, j is less than 4096, j should be lowercase and j plus plus. So in here, if mask sub j equals tile type dot air, then we want the tile, we want done j to be true, because we don't want to do anything with any tiles that are not there. Yeah, makes sense. Haha. And continue, because there's nothing more to check over here. Now we're going to do some other checks. So tile equals seg.get tile. This takes up time again, so we're doing that. All the things that take up the most amount of time, you want to do them as few or less as possible. I don't know which one of the two to use, but doesn't matter. Okay, now if not log tile dot is visible I, then done j equals true as well. So if it isn't visible, it won't done won't be true. Otherwise, done sub j equals false, and continue underscore is false as well, and we'll have to set continue underscore equal to true before this, so continue underscore equals true. Why are we doing this? Well, basically, if we don't have any of the tiles, if there are no tiles visible in this segment on this side, we don't want to loop through all of the x, y, and z values before finding out that there wasn't anything to add to our vertex array. So it's better to add check for this when we're looping through it once, so that well, we can skip the other part. So if continue, then continue, then we're going down to the next side. And this tutorial has already been 11 minutes long, so I see you in the next tutorial where we'll continue on with our world model generator. So I hope I see you then. Bye.